Okay, so here we are at section 1 of chapter 1 of Bittinger's college algebra. And we start right at the beginning with graphs, functions, and models. So right at the beginning, we're going to talk about the very core issue in college algebra, which is functions. This is the first section, as you can see, introduction to graphing, and then we get into the functions and graphs, linear functions, slope and applications, equations of lines and modeling. A little less on that will do. Linear equations, functions, zeros, and applications. We will talk about zeros. So here are the objectives for section 1.1. Plot points, should be easy. Determine whether an ordered pair would be a solution to an equation, that'll be easy. Intercepts, x and y intercepts an equation of the form ax plus by equals c. So as long as it stays in this form, it'll be easy. Graph equations, find the distance between 2 points, equation of a circle with a given center and radius, and given an equation of a circle in standard form. If you're given that, then that's an easy problem. Find the center and radius. Graph equations of circles. So it shouldn't be too challenging. You know the Cartesian coordinate system, also known as the xy plane, also known as the rectangular coordinate system. And so there are 4 quadrants starting in the upper right and going counterclockwise. That's the positive direction in math, the counterclockwise direction. And there are 4 quadrants. And so in the first quadrant, everything is positive. So for example, we might have a point 1, 2, 3, 4, 5, 1, 2, 3, where everything is positive. The 5 is positive and the 3 is positive. But then when the signs change, you end up in a different quadrant. Notice also the x-axis is always the horizontal axis. The y-axis is always the vertical axis. The x-coordinate of the point, the 5 in this case, is the first coordinate, and the y-coordinate of the point is the second coordinate. To graph or plot a point, the first coordinate tells us to move left or right from the origin, the point 0, 0. The second coordinate tells us to move up or down from there, from where we went, left or right. Well, suppose we have a point -3, 5. Well, we're going to go across and then up, right? Across 3 units to the left, and then up 5 units. Plot that point. Equations in 2 variables have solutions x, y. So now we're talking about an equation, but we're talking about the same x and the same y, the same ordered pair that we were talking about when we were talking about the picture or the graph. So here's an example, 2x plus 3y equals 18. When an ordered pair is substituted into the equation, the result is a true equation. the ordered pair has to be a solution of the equation to receive or to be true in that case. Example. Is the ordered pair negative 5, 7 a solution of 2x plus 3y equals 18? Well, of course, what we're going to do is just plug it in. That's the x, that's the y. Throw negative 5 in there for x, 7 in there for y. See if we get the truth. Well, let's see. That's negative 10 and a 21. You add those, you're not going to get 18. You got 11. And 11 equals 18 is a false statement. So we conclude that negative 5, 7 is not a solution. That also tells us something about the graph. Another example. What about 3, 4? Well, plug in the 3 for x and the 4 for y. See if we get the truth. And 6 plus 12 are 18. That is true. 18 equals 18. And we have a solution. Of course, there are infinitely many solutions. So we're saying a lot of things here about the graph. Now, here is an interesting definition-ish about graphing an equation, or the graph of an equation. To graph an equation is to make a drawing that represents the solutions of that equation. Well, I appreciate that Bittinger is at least saying what everyone else is thinking when he puts it this way. In mathematics, the graph of an equation is a set of ordered pairs, which is an issue because a lot of authors of textbooks say that it's not the graph of an equation, which is the set of ordered pairs. It is a function, which is a set of ordered pairs, which actually is not correct. Or a relation is a set of ordered pairs, which is actually not correct. It is correct to say that a graph is a set of ordered pairs. But now he's going to say it's a drawing, which is pretty much what we all mean when we talk about graph. X-intercept, and that is the point at which the graph crosses the x-axis. So we all kind of picture that in our minds, the horizontal axis, the x-axis, and there's a graph, and it's going to cross somewhere. And that point, right, it's a point, so it has two coordinates, x, y. That point is the x-intercept. And x-intercept is a point, A0, right? So it might be 1, 0, 2, 0, 3, 0. And so it's interesting that if we talk about the set of all x-intercepts, what are we talking about? We're talking about all the points on this line. And what is this line? It is the x-axis. And that's where you got to be if you're going to be an x-intercept. So an x-intercept is a point A0. To find A, we let y equal 0. Y equals 0 when you're on the x-axis, right? All these points that we plotted, these are something 0, and y is 0 in that case. So it's interesting that the x-axis is also known, or its equation is y equals 0. The y-axis is the line x equals 0. And so that's kind of surprising sometimes for students, that the x-axis is the line y equals 0, and the y-axis is the line x equals 0. To find A, you've known this since pre-algebra. To find the x-intercept, set y equal to 0, solve for x. To get a y-intercept, set x equals 0, solve for y. Example, find the x-intercept of this point. Well, we're going to let y equal 0 and solve for x. Then 2x equals 18, divide both sides by 2, x equals 9. So 9, 0 is the x-intercept. Y-intercept, set x equal to 0, solve for y. Graphically, it's the point at which the graph crosses the y-axis, or the vertical axis. It's a point 0b. Every point on the y-axis is the point 0 something. Set x equal to 0, solve for y. So in the same equation, set x equal to 0, solve for y. Then 3y is going to equal 18. Divide both sides by 3. Y is 6. 0, 6 is the y-intercept. Okay, so now that was the problem. Find the intercepts. But now we want the bigger problem, graph the line. We know it's a line because, let's see, we've got x to the first here, we've got y to the first here. All of that right there tells you that it's a line or a linear equation. The graph is going to be a line. A line is a graph of a linear equation, and that happens when all the variables x and y are raised to the first power. Okay, so we already found in previous slides the x-intercept 9, 0 and the y-intercept 0, 6. We always like to have a third point as a check, because even though it's true that 2 points determine a line, according to good old Euclid, we could make a mistake, and so we're going to get a third point, because if we had made a mistake, then the 3 points that we end up with won't be collinear. We'll know we'd made a mistake instead of moving on, not knowing that we'd made a mistake. We find a third solution as a check. We put 5 in there for x. Okay, so here's our intercepts chart right here. And if you're just going to get the intercepts, this is what you're getting. So we got 0, 6, we got 9, 0, but let's get a third point in there, 5 something. Put 5 in for x and see what we get for y. We make the substitution. 10 plus 3y equals 18. Subtract 10 from both sides. 3y equals 8. Divide both sides by 3. We get 8/3, or 2 2/3, as the y value. 2 2/3. And so that's also a solution. So now we've got 3 points and we can draw a graph. Okay, so when we are getting the intercepts, which is a great way to graph if we have been given an equation of the form ax plus by equals c. Because it's easy to get the intercepts, set y equal to 0, solve for x, and it's kind of like you could put your thumb over it and solve the resulting equation. And we've already done this, but 2x equals 18, divide both sides by 2, x equals 9, and the point 9, 0 is an x-intercept. X-intercept. Well, to get the y-intercept, we could put the thumb over the x, because we have to set x equal to 0, solve for y to get the y-intercept. So it's as if the 2x isn't there, right? Because we're replacing x with 0, and 2 times 0 is 0, and 0 plus anything is the thing, which is 3y. And so put your thumb over it. 3y equals 18. Divide both sides by 3. Y equals 6, and the y-intercept is 0, 6. And in the previous slide, we also got a third point by substituting 5 for x and solving for y and getting 8/3. We plot the points, and we get points which are in fact collinear, so apparently we didn't make a mistake. Apparently we did not make a mistake. The points are collinear. We know we have the right line, but it's almost impossible to make a mistake with those intercepts, especially if you have form ax plus by equals c. I mean, how do you miss how do you put your thumb over one term and fail to solve correctly a one-step algebra equation? Okay, so there's our line. Well, this one is not going to be linear. We have a 2 in there. It's not just 1 that is the exponent of the variable x, so we're going to get something else here. And so we will make a table of values to get points that are going to go on this graph. All of these order pairs x, y will make the equation that we were given true. How do we get them? Well, let's just take the first one. We'll substitute -3 for x and see what we get for y. So y equals the square of -3, the square of -3. Got to have the parentheses around the -3, right? Minus 9 times that -3 minus 12, which is 9 plus 27 minus 12, which is 36 minus 12, 24. This 24 right here. So the point -3, 24 is going to be on this graph. Similarly, we will get a bunch of other points. So -3, 24, we plot that point, which is about right here. That's that point right there. And a bunch of other points. And 3 points determine a parabola. And so we get that nonlinear graph. Of course, if it's second degree, x is raised to the second power, then we know that graph has to be the graph of a parabola. Distance d between any 2 points, x1, y1, and x2, y2 is this. Okay. Now, if you are given 2 points like that, you could draw a right triangle. And if you have a right triangle, then the Pythagorean theorem is true, which says if you have a right triangle with legs lengths A and B and hypotenuse length C, then A squared plus B squared equals C squared. And in this case, we would take a square root of both sides and get C equals square root a squared plus b squared. Well, that's basically what has been done in order to derive the distance formula, where a is the distance from x1 to x2, or from x2 to x1. Well, the distance is a difference, this difference here, and that's what's going to get squared in the distance formula. But this right here is the big formula there, and that's what we'll want to know in order to find distances. So here we have 2 points, and so there's a point 1 with coordinates x1, y1. Here's an x2, y2. We will apply the distance formula. The distance formula tells us that the distance between the 2 points in the plane is the square root of the sum of the squares of the differences between the x and y coordinates respectively. So x2 minus x1, which is negative, so we're going to be subtracting a negative here. We don't want to make the mistake of dropping a negative when you have 3 minus negative 2, for example. And a negative 6 and a 2, y2 minus y1. So it's going to be the square root of the sum of the squares of 5 and negative 8, respectively. And so we're adding 25 and 64. The square of a negative is a positive, right? Negative 8 times negative 8 is positive 64. We're adding those to get 89, and then take a square root, and you've got your distance. Now, they didn't say in the problem to give a decimal approximation, so that's really the answer right there, unless they say approximate to the nearest tenth the distance. So there's a picture, and it does look like it's about 9 units-ish between the 2 points. Well, we can't have a distance formula without having a midpoint formula. And so you can see the logic of this. Here's a midpoint with a first coordinate, an x coordinate, and a second coordinate, a y coordinate, where the first coordinate, the x coordinate of this midpoint right here between midpoint of a line segment, the x coordinate is the average of the 2 x coordinates. Okay, so if you take these two numbers, these 2 x coordinates, there's one here, the x coordinate here is x1. The average of the 2 puts you right there in the horizontal where you need to be to have an x coordinate at the midpoint. And as for the y coordinate, well, of course, that's going to be the average of the 2 y coordinates, and that'll give us the y coordinate of the midpoint. And well, how do you get an average of 2 things? Well, you add them and divide by 2, right? That's how you get an average of 2 things. And so that's all we're doing, 2 times, one for the x and one for the y, for the midpoint. Example, find the midpoint for that segment. And so we'll get the average of the two x coordinates, add them and divide by 2. The average of the two y coordinates, add them and divide by 2. And that'll be the coordinates of the midpoint. Negative 4 plus 2 are negative 2. Then we're going to divide by 2 to get negative 1 for the x coordinate of the midpoint. And the y coordinate is 3 over 2. Well, if you look at it, it does look like the point negative 1, 3/2. 1 across to the left and 1.5 or 3/2 up from there. That does look like it's halfway between the two endpoints of the line segment that has endpoints, the points we were given. So circle, set of all points in the plane the same distance from a given point called the center. We call that distance r, and we call the center hk. So equation of a circle with center hk and radius r in standard form is. So this is the important formula about circles that you have to remember. And the important thing is that you remember that this is the standard form, because standard form is not the only form. Find an equation of a circle having radius 5 and center 3, negative 7. So we go to our standard form, and here we have h equals 3, k equals negative 7. I always remember my friend's cat, HK, which stands for Hairy Kitty. But h is the x-coordinate of the center, k is the y-coordinate of the center, and in this case r is 5. And so we're going to make those three substitutions for h, k, and r respectively, and then work out the math of that. Notice we're squaring the r, so we're going to have 25 on the right hand side, and on the inside we have x minus 3 and a y plus 7, since we're subtracting a negative, which happens before the squaring. And so that's it. That's the equation of the circle, and that concludes this long video, kind of necessity. There's a reason why this is also affected by Hurricane Harvey, which I won't go into, but the good news is that there's only one video for this section that you have to watch and not a bunch of videos. It'd be better to have a bunch, but Harvey did not agree today.